this video, we're going to look at how to take the logarithm, the natural logarithm, of a complex number given in the standard form. So to do it, we need to use the following result, which is going to be something that we haven't seen in these videos up to this point, but we're just going to state it. We're not going to prove it because the proof is a bit complicated, but it's something that you'll probably see at some point in your studies if you're studying complex numbers. So the result is that r times cos theta plus I sine theta is equal to r times e to the I theta. So hopefully the thing on the left is at least something you recognize, especially if you've watched the previous videos in this series, because it's just a complex number expressed in polar form. So r is the modulus, theta is the principal argument, and we have r times cos theta plus I sine theta. That's just a complex number in polar form, and this equation tells us that it's equal to re to the I theta. So this is a very important equation in mathematics. It comes up a lot and it tells us a lot. We can use it in many different ways, but in this video we're just going to use it to calculate the logarithm of a complex number. So I'm not going to prove it as I say, but just take it as a given that if you have a number in polar form, there's essentially two ways of writing it. So if you have a number in polar form, you could write it in this way on the left hand side, which is called the polar form, or this way on the right hand side, which is called the exponential form. But the two are equal. So if you have the modulus and the argument, you can write it in either way. So let's use this result to look at the logarithm of a complex number. So if we take the natural log of z, it's equal to the natural log of a plus bi. So any complex number can be expressed in the form a plus bi. So say we have it in that form, then we know that we can convert it to the polar form using the method that we've seen in previous videos. So if you have it in standard form, you can find r and theta and write it in polar form. And we know that that's equal to re to the I theta, just using the box at the top. So once we found r and theta by, well, usually we draw a diagram, do some trigonometry to find the angle theta and the length r, we can write the exponential form down. So we have that log of a plus bi is equal to log of re to the I theta. But now we use the rules of logs, which hopefully you're familiar with. So if you have the log of two things multiplied together, so the log of ab, it's equal to the log of a plus the log of b. So that's just a standard rule for logs. So we have that this is equal to the log of r plus the log of e to the I theta. But natural log and e are the inverse of each other. Hopefully you've seen this, they cancel out. So this is just equal to log r plus I theta. So in this second term, the log and the e have cancelled out, and we're just left with the power, which was I theta. So this is now in standard form, a plus bi. It doesn't maybe look like it is, but log of r, since r is just a real number, log of r is also a real number, so that's our real part. And then our imaginary part, b, is just theta, because we have theta times I. So it is possible, if you're given a number in the form a plus bi and you take the log of it, you can write the answer also in that form by first finding r and theta, so doing a bit of maths to find these two numbers, which we use for the polar form, and then writing the number in its exponential form, using the equation in the top box, and then doing this using the rule of logs to do these few final lines to get the answer. So let's look at a quick example. We want to write the log of 1 plus I in the form a plus bi. Well, we need to find r and theta. So we've done that in previous videos. We'll do it again quickly in this one. The solution is we're going to draw a quick sketch. So where is 1 plus I in my complex plane? Well, we go 1 along the real axis and 1 up the imaginary axis to I. So it's here where these two lines meet. So this is the number, this black dot is the number 1 plus I, and the length of this line here is r, and this angle here is theta. Okay, so r is equal to the square root of 1 plus 1, that's just using Pythagoras' theorem, or just the standard definition for r, that it's the square root of a squared plus b squared, which comes from Pythagoras' theorem. So that's just equal to root 2. And then theta, hopefully you can see, is just equal to pi by 4 because it's half of a right angle. because this is a square we've drawn here with these dotted lines, and the line that has length r is going across from one corner to the other, so it's cutting the right angle in the corner of the square in half. So half of a right angle, which is pi by 2, is pi by 4. So theta is equal to pi by 4. So we don't even need to do any trigonometry, we don't need to use SOHCAHTOA. Once we've drawn our diagram, we can just see that theta is pi by 4. So now let's use this information on the right hand side to calculate log of 1 plus I. 1 plus I, written in the exponential form, is square root 2 times e to the power pi over 4i. So that's just using the top box there on the left hand side. So we have that, and then that means that the log of 1 plus I is equal to the log of square root 2 e to the power pi over 4i. But we just said, using this information on the left, what this is equal to. So let's literally just use the bottom line from the left hand side box. We said that this is equal to log r plus I theta. So that's log of root 2 plus pi over 4i. So I'm just using the derivation on the left hand side to write down straight away what log of 1 plus I is. So all you need to do is find r and theta, and we've done that before. We know what r and theta are defined to be. It's just the r and theta from the polar form of the complex number. Once you've found them, you can just plug them in to the equation that comes from the box on the left hand side, and we get log r plus I theta. You could, if you wanted to, calculate what log of square root of 2 is as a decimal. You'd put it into your calculator and you'd get a decimal approximation, and you could put pi over 4 into your calculator to get a decimal approximation for that, but it's perfectly fine to just leave them in the form they're in, log of square root 2 and pi over 4. So that's our solution. Log of square root 2 plus pi over 4i is the log of 1 plus I.